Assalamu alaikum. So today we are going to know about the introduction to computing, that is chapter 0. So this chapter includes the basic knowledge of AVR, microcontrollers, and embedded system using assembly and C language. So basically, these are the topics we are going to cover, as there will be internal organization of computers that contains of different parts of a computer, such that input output, memory, central processing unit. And if we talk about connecting to the different parts, so it includes connecting to CPU and input and output pins towards CPU. So basically we will know about how computers work. So its main components involve CPU, memory, input and output pins. If we take example of input pins, we will get keyboard, mouse, sensor. If we talk about output, so there will be LCD, printer, hands of a robot and extra. So basically what is the memory? Memory can be defined as everything that can store, retain and recall information. So it can be RAM, it can be ROM, it can be temporary memory, and it can be a permanent memory. So as we know that it can store data. The memory can store data, for example 1 to 8 KB and 256 megabytes. And where are the location and how are these organized? So basically 1 to 8 into 4 memory has 128 locations, and each location has 4 bit. Okay, so then if we want to know about semiconductors examples, so the RAMs that we use in our mobile laptops and computers are example of semiconductors. And if you talk about non-semiconductors, so we will get floppy disks and examples. So semiconductor memories include ROM, including mask ROM, S meaning static RAM, dynamic RAM, non-volatile RAM, and EEPROM and flash EEPROM and erasable EEPROM. Then programmed by IC manufacturer. And OTP, it is called one-time programmable. You can program it once, only once. If we talk about UV EEPROM, so it can be defined as that you can shine ultraviolet UV radiation to erase it. Erasing up to 20 minutes, the entire contents of ROM are erased electrically. So it contains that data can be erased instantly and separately. And then it can be erased at once in flash memory. So this was the basic difference. If we talk about semiconductor, so this also include same RAMs. If we talk about static RAMs, it is faster, no need for refreshing, but it has some disadvantages like high power consumption and it is expensive. So DRAM, which is called as dynamic RAM, its advantages are less power consumption, cheaper, high capacity, and disadvantages are slower refresh needed. And if we talk about non-volatile RAM, these are made of SRAM battery control circuitry. These are very fast, infinite program array cycles, non-volatile. Disadvantages include expensive tasks. It should execute instruction. It can recall the instruction after one another and execute them. So this was the definition of a simple CPU. So connecting memory to CPU. So we have digital and analog pins that are connected. These and the separate pins are ground, and the other pins are ground and VCC. So this is the basic connection. This is the process that how to write data to memory. This is from reading from memory. Okay, this is the basic architecture of how data is stored through input output pins into CPU. So this include address bus, data bus, control bus, and same like that. Uh, this is connecting input output and memory to CPU pin bus. This is the example. This is the flowchart. Okay, then connecting to peripheral input output means this is the so basically this blue line indicates address bus, green bus line indicates data bus, and these brown lines indicate control bus, and the red line indicates input output memory. So the logic circuit enables CS when address is between 0 and 15. And how could we make the circuit? So it basically writes in binary code in 0 1 format, and then we use NAND technology to make the circuit. This is the whole procedure as written in example, and this is the conversion as we have seen this conversion in DLD in our previous course. This is hexadecimal systems. We have already studied them in DLD course in fourth chapter. These all are conversion that we have done earlier. So basically, we have just to show them again. So this is the process of two's complement. Okay, so this is the ASCII American Standard Code for Information and Exchange. This is equivalent to this and up to so on. So these are continued. And another example of address decoder is address of 300H to address of 3FFH. So we have to convert this into binary, into all this also into binary, and then we will perform design the digital circuit as we have studied in CPU. Basically, what is inside the CPU? So there is a arithmetic logic unit, the program counter, the registers, and instruction decoders. This was the old schematic. This was the old block diagram of how computer works. So the data is transferred to the CPU through input output pins, and then it is uh, gone to the address bus. After that, it will store to the CPU and it will perform several functions what we have required. Uh, this is the Harvard architecture, and this is the non-Newman architecture. Von Neumann architecture. So these are the general purpose microprocessor and microcontrollers. Uh,